Hey, Bogdan Brzeski here, where we make algebra easy just for you. Welcome to another video. In this video, we'll be going over factoring trinomials AI-assisted summary. You may find it interesting because you can actually participate in your own learning journey very actively. So you have videos, access to a lot of videos, a lot of resources as you mastering your skills, and you can actually use those resources so that you can create more resources based on what you have learned in the form of a summary. So that is helpful when you're studying for a test, when you're creating a summary note for preparation for the exam. So today I'm sharing with you the AI assisted version, and you probably know about it. This is based on Google AI, and this is called Notebook LM. Free account. I have no association with them, so there is no sponsorship here involved whatsoever. But I have come across that tool, and I understand that the quality of the input that you would utilize when working with it will give you that quality of the output. So when you have your Google account set up, most of you do have it via school that you're attending, or you can just create your own. And then when you open from Google Drive, when you open this little platform, so this is called Notebook LM. You can recognize this by that. Let me just get my. Okay, so this is basically the icon that you're looking for. And this, on the screen, you will see three major columns. The resources that you will input here. So the sources that I used, I uploaded sources that I understand were good and reliable. Then you will have a studio based on the sources that you create. You can create all kinds of aids and helpful things, including video. And I'm going to link that video right here so you will be able to watch when learning about what is the best strategy when factoring trinomials. So there is a summary here that you can create a text by yourself, or the machine does it for you, but I suggest the machine starts with the summary and you create with your own words the stuff that you're looking for based on the sources that you came across. Could be your notebooks, could be your notes from your classroom, from your subject teachers, from videos that you watch, etc. So once you have this, you will go to Studio, which is on the right-hand side, and you start taking advantage of possible summary in different modalities. For example, you can create a flashcards that comes with answers based on the resources that you have provided. Then you can create a little quiz if you're studying for the upcoming test and you want more questions and you know that you have exhausted so many videos, etc., but you're looking for something extra, so you can create quizzes based on sources that you uploaded. Then you have mind map. Sometimes this is a very good visual aid you'll find for yourself, that you can see what is important for me to understand, what is important for me to memorize, and how to review the skills that I have learned about in the last whatever number of weeks and days, etc. And then you can create a study guides also. Let's say you want to create a summary based on sources that you have inputted. It also will give you a document form that you can copy and paste in your own notes. Also, you will get the video that you will be watching momentarily, and also an audio podcast that you can actually opt for that. This is a very good source of information when it's summarizing you in a sort of audio form, so you can do other things while listening, and that could be very helpful for you. So without further ado, let's watch the video that the machine generate, and then you'll give the assessment yourself by watching it, and hopefully you find it very useful. And let me know in the comments below if you would love to use more and more of AI generate assisting tools on your journey in learning mathematics. Thanks for watching. We'll see you next time. Bye for now.
Let's talk about factoring polynomials. I know, for a lot of us, that phrase can bring back some, let's just say, confusing memories. It can feel like this endless pile of rules. But what if I told you it's way less about memorizing 100 different things and more about having one simple, powerful strategy? Well, that's what we're going to do. Let's dive into a toolkit that's going to make you a master at factoring. Okay, first things first, let's get one thing straight. Factoring, it's just multiplication in reverse. It's like undoing a puzzle. You already know how to use FOIL to multiply two things, like x plus 2 and x plus 6, to get that trinomial on the left. Well, factoring is just starting with the answer and working backwards to find the original pieces. We're just unmultiplying. That's it. But here's the classic problem, right? You're staring at a polynomial on a test and your mind just goes blank. Is this a difference of squares? Do I need to group? What's the very first step? That feeling, that paralysis of not knowing where to even start, that's exactly what the strategic toolkit is designed to destroy. So here's our game plan. 4 simple sequential steps. First up, we've got the golden rule. You can never, ever skip this. Then, a decision map that's all based on how many terms you're looking at. After that, we'll get into some expert-level shortcuts. And finally, your secret weapon to make sure you are always 100% correct. All right, let's get into it. Step 1, the golden rule. You have to hear me on this, always, and I mean always, check for the greatest common factor first. It doesn't matter what the polynomial looks like, this is your non-negotiable starting point. It makes every other step so much easier. So what even is the GCF? Think of it as the biggest chunk of stuff, numbers and variables, that's common to every single piece of the polynomial. And the key word there is every. If it's not a factor in one of the terms, it's out. It can't be part of the GCF. And finding it is actually pretty straightforward. You just break each term down into its smallest building blocks. You know, its prime factors. Then you look at all the pieces and find everything they have in common. A great little shortcut for the variables is to just grab the one with the lowest exponent. That common stuff, that's your GCF. Then you just pull it out front. Okay, check this table out. It makes it super clear. We break down 9x cubed and 6x squared. Look what they have in common. You can see it highlighted. They both have 1, 3, and they both have 2 x's. So you put that together and boom, our GCF is 3x squared. So once we've found that GCF, we just pull it out to the front of the line, just like you see here with the 3x squared. Now to figure out what's left inside the parentheses, all we do is divide each of our original terms by that GCF. So 9x cubed divided by 3x squared leaves us with 3x, and negative 6x squared divided by 3x squared is negative 2. And there's our final factored form. Okay, golden rule. Done. You've yanked out a GCF. So, now what? Well, let's move to the next tool, which is all about counting. You just count the number of terms left inside those parentheses. That number is going to tell you exactly which method to use next. It's like a roadmap. And this is your decision tree. It's really that simple. If you see 4 terms, your brain should immediately think, factoring by grouping. If you see 3 terms, that's your classic trinomial. We're going to use the product sum method. And if you're down to just 2 terms, a binomial, you need to be on high alert for a special pattern called a difference of squares. All right, let's go down that first path on our map. You've got 4 terms staring back at you. This is the perfect setup for a technique called factoring by grouping. The whole strategy here is to turn one big, annoying problem into 2 smaller, manageable ones. See, in step 1, we just put parentheses around the first 2 terms and the last 2 terms. Then in step 2, we find the GCF of each little group. For the first pair, it's x squared. For the second, it's a 2. And here's where the magic happens. Look, both groups now share the exact same binomial, x minus 3. That shared part is our new GCF, and we just factor it out in step 3 to get our final answer. Now, this method is super powerful, but there is one little trap that gets people all the time. Can you guess what it is? It's all about the plus and minus signs. And there it is. When your second group starts with a minus sign and you factor out a negative number, you have to remember to flip the sign of the second term inside the parentheses. So for instance, if you're factoring -4 out of -4x plus 8, you're left with x minus 2, right? Because that -4 times a -2 gets you back to that positive 8. Watch out for that one. Okay, so let's move on to three-term polynomials, the trinomials. At its heart, factoring these is like solving a little puzzle. Just look at this table for a second. We're on a hunt for two magic numbers. These numbers have to do two jobs at once. They need to multiply to get our target product, in this case -30, and at the exact same time, they need to add up to a target sum of 13. Finding those two numbers, that's the whole game right there. Now for the more complex trinomials, the ones where that first number isn't just a 1, we use this awesome method called decomposition. Let's walk through this example. First, we find our magic numbers. As step 1 shows, we need a product of a times c, that's 24, and a sum of b, which is -10. A little thought, and we find the numbers are -6 and -4. Then you use them to literally break apart or decompose that middle term into -6x and -4x. Now look what happened. All of a sudden, we have a 4-term polynomial, which we already know how to solve using grouping. It's a fantastic little trick. So what happens if you're only left with 2 terms? The very first thing you should check for is a difference of squares. Honestly, this one is just a pattern recognition game. Ask yourself 2 questions. Are both terms perfect squares? And is there a minus sign between them? If the answer is yes to both, you're in luck. The formula is super simple. It just factors into 2 binomials with the same stuff but opposite signs, like you see here, a plus b times a minus b. Okay, let's move on to our third tool. And this isn't about learning more complicated rules. This is about training your eyes to spot patterns. When you can recognize these special cases, it's like having a secret shortcut that lets you jump right to the answer. It'll save you a ton of time. This slide shows 2 of the most powerful patterns side by side. On the left, we've got our difference of squares again. See it? 2 terms, both perfect squares with a minus sign in between. Easy. Now look to the right at the perfect square trinomial. This one has 3 terms. The first term, 4x squared, is a perfect square. The last term, 25, is also a perfect square. But here's the crucial check. Look at that middle term. Is it 2 times the product of their square roots? Well, the square roots are 2x and 5. Their product is 10x. Times 2 is 20x. It's a perfect match. That means we know it's a special pattern. And now for the final and maybe the most empowering tool in our entire kit, your secret weapon. This is the step that lets you finish a problem and walk away with absolute 100% confidence that you got it right. No more guessing. So how do you use this secret weapon? It's so simple it feels like cheating. You just multiply your answer back out using FOIL. Do the reverse of what we learned at the very beginning. If you get the exact same polynomial you started with, you nailed it. Period. It's a built-in guarantee that you're correct. And hey, don't just take my word for it. This isn't just about getting the right answer on a test. As a lot of educators will tell you, verification is a critical part of the learning process itself. It really hammers home that core idea we started with, that multiplication and factoring are just 2 sides of the very same coin. So, we've built our entire strategic toolkit. Now, to make sure it really sticks, I'm going to leave you with one final question to think about. After everything we've covered, the next time you're faced with a factoring problem, what is the absolute number 1 first thing you're going to look for?